Welcome to this interactive particle life simulation. Think of this web app as a digital sandbox where we explore emergent complexity, how complicated lifelike patterns can arise from very simple local rules. You're looking at thousands of tiny colored particles bouncing around in a dark space. What are you seeing? Essentially, you are watching a microscopic, abstract world governed entirely by force interactions. The particles? They are just dots of different colors, or types. In the controls panel, you can set how many colors are involved, from 2 up to 6. The rules? The magic. The key is the force matrix you can click on in the controls. This grid defines how every particle type interacts with every other type. Attraction, green in the matrix, if a particle of type A likes type B, it pulls it closer. Repulsion, red in the matrix, if type A dislikes type B, it pushes it away. Neutral, black or gray, no strong interaction. By tweaking these simple attraction-repulsion values, you can suddenly get wild, organized structures that look like microscopic organisms, chains, or crystalline patterns, all without having coded those shapes directly. How to play? The simulation is running right now, but you can take control. Change the population. Slide the particles control to see the system behave with more or fewer individuals. Change the rules in real time. Force. Use the force slider to make attractions or repulsions stronger or weaker. Radius. Adjust the radius to change how far particles can sense each other. Smaller radii mean particles only react to their immediate neighbors. Tune the forces. Click on the cells in the force matrix in the control panel. This is where you become the god of this universe, setting the attraction or repulsion between every pair of colors. Try setting all type 1 versus type 2 forces to strong attraction to see them cluster. Demo mode. Hit the Play Demo button. It will automatically cycle through several fascinating force setups that create beautiful, complex, lifelike motions, like the worm-like structures or clustering you saw in the inspiration video. It even starts automatically if you leave the page idle for 10 seconds. Under the hood, the technical side, this isn't running on a heavy game engine. It's built with basic web tech. Canvas rendering. All the drawing happens directly onto an HTML canvas element using JavaScript. The cool, glowing look is achieved by drawing transparent colors and blending them together using the lighter composite mode. Performance focus. Since calculating forces between thousands of particles is computationally expensive, the underlying physics logic is designed to be fast, though it still slows down if you push the particle count too high. The compute shader videos you saw referenced in the source material use the GPU to massively speed this up, but this version keeps the core math running efficiently on the CPU within the browser. Density regulation. This is a neat trick to stop the simulation from just collapsing into one giant boring blob. If particles of the same color cluster too tightly, this feature subtly weakens their attraction, encouraging them to spread out into more stable, interesting shapes. In short, this application is a playground for exploring complex systems, showing how simple, local interactions, repeated many times, lead to surprising and beautiful global order. Feel free to experiment.
Right, well, there you go. This was description by Gemini 2.5 Pro. The code was created by 2.5 Pro as well.